All right, today in class we worked on lots of things, but one of the focuses was writing expressions, like algebraic expressions, which you see here on the left, and then equations, which we have here on the right. And the smartboard has been unpredictable, so it's not oriented very well, so I'm going to be typing because it's not allowing me to write on it where I want to all the time. But I just want to do a quick review to help you with your homework. So we're going to focus in on this one page here on the right-hand side. And we're going to transition from doing expressions, which do not have equals, but they do have operations like subtract or a dot for multiply or addition or even division, and variables, which are the letters, things that change. And then there's numbers. A lot of times there's numbers. So here's the situation. Miss Carol and Miss Carew are so excited about the spring fling on Wednesday after school. Miss Carew wants to buy glow bracelets that are $1.25 each. So when you're doing a problem like this, remember that there's some key information that we might want to identify. Like that's important, $1.25 each. And we want to write an equation, which means that we're going to have an equal sign in the equation. So that's a key word. And then the variable, we're going to write an equation that represents the cost C, that's our variable, to the number of bracelets N, that's another variable. So this problem has two variables. And this is the equation below to represent this problem. Now, we're going to practice some of these when they're not finished, but let's look at one that's finished. C represents the cost, and it's dependent upon how much each bracelet is. So in other words, if you have to pay $1.25 for each bracelet, your overall cost is going to depend on how many bracelets you buy. So N is the independent variable. In other words, if you buy one bracelet, you only pay $1.25. If you buy two bracelets, you pay $2.50. And if you buy three bracelets, you pay $3.75. Sometimes, let me try a table here. Sometimes you can make a table to help you figure this out. So the number of bracelets is your independent variable, and if you buy one bracelet, you only have to pay 1 times $1.25. So your total cost is just $1.25. But if you buy two bracelets, then you have to pay 2 times $1.25. So your total cost is $2.50. If you buy 3 bracelets, then you have to pay 3 times $1.25. And the pattern's going to continue. This would be $3.75. But what I want you to notice about the pattern is the variable changes. This number changes in the problem, but the 125 stays the same. Okay. So since the 125 is in each problem, it's going to be in our final equation. So what we would say is the cost is found out by taking the variable times the 125 each time. And since the variable changes, we say the number of bracelets times $1.25. That's how we think about it. But usually in algebra, the number, the actual non-variable part of the equation comes first, and then the variable part. That's how we write the expression. So the cost is $1.25 times N. This $1.25 is called a coefficient. It's the actual number, not a variable. So let's practice a few examples. Write an equation for each of the following situations. At the spring fling, Lucy wants to buy Sour Patch Kids that are $1 each. Write an equation, so we need an equal sign that represents the cost, so C is going to be our variable, to the number of boxes she can purchase. N represents the number of boxes. So if I made a little table, cost, as my dependent variable, and N as the number of boxes, I know that for one box, I would have to do 1 times $1. It's pretty straightforward, that's $1. But if I bought 2 boxes, I would have to do 2 times $1. So now $2. If I bought 3 boxes, I would have to have 3 times $1. So when I look at this pattern, what I notice is to find cost, I have to take this $1 is in all 3 problems. So I have to say the cost is $1, and I'm not going to put the decimals in because it's a whole number, times the variable which changes. That variable, the variable here changes, and it's the number of boxes. So my cost is 1 times the number of boxes. And that's my whole equation. Cost is 1 times the number of boxes. Here's another problem, number 2. Hot lunch for the middle school is $3.50 for a lunch. I want to write an equation, which means I have to have an equal sign that represents the cost to the number of meals. Each meal is $3.50. So the meal is my independent variable, and the cost is my dependent variable. C is my dependent variable. Usually in the equations, well, the board's starting to not work again. Go back to the computer. In equations, if you look at the previous page here, go to 2 pages, the dependent variable is alone, and then the independent variable is with the expression on the other page, on the other side of the equals. Sorry about that. So if I want to do an equation for this, I'm going to say cost is equal to the number of meals times 350, because for every meal I have to spend $3.50. So if I have 1 meal, I only spend $3.50, but if I bought 2 meals, I would spend $7. So since the number of meals changes, that's my variable. Okay, so number 3 and number 4, maybe take a minute at home and write equations for those, and pause this video, and then when you have the equations, compare your answers with mine. Okay, so check your work. Cost, there we go, is going to be equal to 5 times the number of tickets. And on this last one, Nico can skate 10 miles per hour on his skateboard. Write an equation that represents the distance to the number of hours, h. So on that problem, think about a little bit more here. We know that we can make a little table here and figure out his distance, because it depends on his rate. So his distance might be different depending on how many hours he skates. So if he skates 1 hour, his distance is going to be 1 times 10. Oh boy, the board is really bad now. If he skates 2 hours, his distance is going to be 2 times 10. Those are supposed to be tens. Better type. Okay, so since the board's not working, I typed in the table, but going back to that problem, we talked about if you skate for 1 hour, you're going to do 1 times 10 or 10 miles. If you skate for 2 hours, you'll get 20 miles because you would do 2 times 10. And if you skate for 3 hours, you would do 30 miles, 4 hours, 40 miles. So if you did n hours, you would have to do n times 10 miles. And so when you look at this, again, the 10 is in every single one of these. And so 10 has to be in our final equation. And this number changes. And so our equation that we're going to write is the distance is equal to 10 because it's in every single one of those problems. The distance is equal to 10 times the number of hours. All of those, and when we multiply, we can just put things right next to each other. We don't even need the dot. And these really should have been H's there. That should be a little H for hours. So your job today is to do the same thing on this worksheet, your homework tonight. You're going to write expressions for some of these situations, just like we did in class today, expressions. And then your other job is to sometimes write equations. So every once in a while, you'll look through this, and if you see the word equation, then you have to do something with an equal sign, like this example we just finished.